Okay, here's your Module 5 lab activity. It's all about buoyancy, and this is really it's about Archimedes' principle. Um, and it's very similar to a lab that traditional students do, a hands-on lab. Well, the best we can do is a simulation. But here's your splashdown page. We can go ahead and we hit begin. You'll notice this guy, that's not Archimedes, I don't think. I think that's supposed to be Isaac Newton. But in any case, notice that there are several controls that are possible in this simulation. You can change your location. To do the first question, they do specify that you do stay here on Earth. Notice you can also change the fluid that's in your container. Again, the first question specifies that you stay with fresh water. And then you can change the mass of your bottle as well as its volume. Now, in this first one, you use the default values. You use the volume of 500 milliliters. You use the mass of 1,000 grams. And then you go ahead and you hit start. And you go ahead and notice you have a graph. You have a graph that represents the force that's read by your force sensor that good old Isaac is holding onto, as well as the time. Okay, so it's a force versus time graph. Go ahead and let it go for the entire 16 seconds, complete the run, and then answer a couple of questions. Now, down in question 4, you have to create a data table. And the data table has a lot of a fair number of columns, right? It's got a massive bottle, so you hit reset. Now you want to be changing the mass of your bottle for your different runs. You can change the volume of the bottle if you wish, etc., etc. But what's important is that you take the force in air, meaning you want to get a force reading in air, the force in the fluid. So no matter what your mass and volume are, go ahead and do a run and see how much force your force sensor is detecting while the bottle's before it gets submerged. Then take the force reading after it's been completely submerged. Then you take the difference. There's a force difference column. Then you also have to have the volume of water displaced and the weight of water displaced. Now there is a very important note below that data table in question 4. It says, where is it? In order to calculate the last column, the weight of the water displaced, you need to multiply the volume of water displaced by the weight density of water, and I give you that value. So there's some math involved here, and I give you an example. Of course, in order to do this calculation, you need to know how much water is displaced in each trial. And if you don't know this by now, you really don't understand Archimedes' principle. So please review that. How would you figure out the amount of water that gets displaced, the volume of water displaced? If you don't understand that, you don't understand Archimedes' principle. Okay, so then that will complete your question 4. You're supposed to take a screenshot of the data table that you create. Questions 5, 6, and 7. Now you get a chance to play around with the different materials, the different fluids. You can change your fluids, and it asks you to rank a couple of ranking tasks involving the different fluids, as well as in question 7, you're going to vary the location. So you're going to keep your fluid the same and then change your location. And that's how the whole activity wraps up. Good luck.